This is the Chapter 8 review presentation for geometry, and what we're going to do today is we're going to go over some of the types of problems I'm going to expect you to be able to do on your Chapter 8 assessment. We're just going to go over a few problems, cover some concepts that we've done throughout this chapter, and then if you're really good, at the end of this presentation, I'm going to introduce one new amazing, wonderful figure, one that we've not seen before, and no need to worry, won't be tested on it, but I'm pretty excited to show it to you, and we'll hopefully really like it. So here we go. So first type of problem I'll expect you to be able to do. The sum of the interior angles of a regular polygon is 3,960 degrees. Classify the polygon by the number of sides and the measure of each interior angle. So this is going to be the formula of n minus 2 times 180 equals the total number of degrees inside the polygon. And the reason why that equation works is that if I take the number of sides that a figure has and I subtract 2, that's a number of triangles that I can draw inside by connecting diagonals. So I take the number of sides, subtract 2, and then multiply that number times 180, and that gets my total number of degrees inside of a figure. So my equation is going to look like this. Now, because I have two things multiplied times each other, the n minus 2 and the 180, I can divide both sides by 180. And if I divide both sides by 180, the 180s on the left are going to cancel. And then on the right side, I take 3,960 and divide it by 180, and that's going to give me 22. So on the left, when the 180s cancel, I'm left with just the n minus 2. On the right, I'm left with 22, and then to figure this out, I just add 2 to both sides. So my 2's here are going to cancel. So I just add 2 to both sides. And 22 and 2 added together is going to be 24. So this polygon is 24 sides. And then to find the measure of each interior angle, I just take the total number of degrees, which is 3,960, and divide that by 24. And that will give me the measure of each interior angle. So each interior angle then measures 165 degrees. All right, let's move on to the next type of problem. Okay, so I've got two of them here on this page. I'll start with the one on the left, and then I'll do the one on the right in a moment. So you'll notice here I've got a quadrilateral. I've marked these two sides congruent, and then I've marked these two sides over here congruent and parallel. So there's 5 different ways that we can prove that a quadrilateral is a parallelogram. One of the 2 ways is that I have opposite sides congruent, and I have this. I have these sides congruent, and then I have these sides congruent. So this is one of the 5 ways I can prove a parallelogram, or a quadrilateral is a parallelogram. And then my favorite way is if I have a set of sides congruent and parallel, and I have a congruency mark here and here, I have parallel v's marked here and here. So this is another one of the 2 or 5 ways that I can prove that a quadrilateral is a parallelogram. So I've got a parallelogram here, and opposite angles in a parallelogram are just equal to each other. So if this is 98 degrees here, then x is also going to be 98 degrees as well. Now let's move on to the problem on the right. So here I just have a set of sides marked parallel to each other. Nothing else is marked. So I've got a trapezoid going on here, and angles in between, or I guess angles between bases here, because these are bases here, these are bases, and over here are legs. Angles between bases here, like this, are going to be equal to 180 degrees. They're supplementary. They're also like alternate interior angles. So I like an angle here and an angle here. This is like a transversal crossing 2 parallel lines. So I just take 180 degrees and subtract 143 degrees, and then this angle here then is going to be 37 degrees. And that's how we do these types of problems. All right, over here I want to figure out what x is. So my goal here is to figure out what this is, but there's some work I've got to do first before I can get to that. I've got a kite. I've got 2 sets of congruent consecutive sides. So these 2 sides are congruent. Down here, these 2 sides are congruent. So I have a kite. These are my vertex angles here because they're between my congruent sides. And then these are my non-vertex angles. And on a kite, non-vertex angles are congruent to each other. So angle W is going to be congruent to angle Y. So angle W is 110 degrees, and that can help us find X then. So total inside of a quadrilateral is 360 degrees. So a quadrilateral has 360 degrees inside of it, and a kite is just a special quadrilateral. So then in order to figure out the measure of X, I'm going to take 360 degrees, and I'm just going to subtract these three angles here. So I'm going to subtract 110 degrees twice, and then I'm going to subtract these 85 degrees down here, and that's going to leave me with a total of 55 degrees. And that's how I do this type of problem. All right, so here I've got a hexagon, and I've got a lot of angles marked, and I want to try to figure out the measure of X here. So I want to figure out this angle right here. So a set of exterior angles is 360 degrees, no matter how many sides it's got. It's got 2 sides, it's got 20 sides, it's got 5 sides. It's 360 degrees for a total set of exterior angles. So all I need to do is subtract all of my exterior angles, and I'm going to figure out the measure of X. Now, this one's easy. It's 45 degrees for this exterior angle. This one's 60. This one's 65. This one's 70. But this other one over here is tricky. I didn't give you the measure of the exterior angle. I'll give you the measure of the interior angle. So these two angles are 180 degrees. They form a straight line. They're a linear pair. So if I take 180 minus 120 degrees, I'm going to get 60 degrees. So the measure of this exterior angle here is 60. So in order to figure out X now, I just take 360 and I subtract 45, 60, 65, 70, and 60. And that's going to leave me with 60 degrees. And that's how I do this type of problem. All right, so same deal. Set of exterior angles is 360 degrees, and I have one angle here. And this has 5 sides. So I'm just going to take 360 and I'm going to divide it by 5. And 360 degrees divided by 5 is going to be 72 degrees. So X is 72 degrees. All right, taking a look at this. I've got a parallelogram marked here. I have 2 sets of parallel sides here, and I have 2 sets of parallel sides here. And one of the major concepts from this section is that consecutive angles in a parallelogram are supplementary no matter where they are. So these are supplementary, these are supplementary, these are supplementary, and these are supplementary. So I'm just going to end up having these two added up together to equal 180 degrees. So this is going to be x plus 2x equals 180 degrees. X and 2x added together are going to be 3x. So these two I can combine together to make 3x. And then I just take 180 divided by 3, and I'm going to get 60. So this is 60 degrees here, and then this one is 2 times 60 at 120 degrees. But I only needed to find x. So in this case, x is just 60 degrees. All right, so you'll notice here that I've got a trapezoid going on here, and I've got a mid-segment here that's parallel to my bases. And basically the concept that we've got going on here is that a mid-segment is equal to the average of the lengths of the bases. So if I take this number and add them up and divide by 2, that's going to give me the length of this number. So if I go x plus 15 divided by 2 is going to equal 10. And then to solve this, I'm just going to multiply both sides times 2. So this is going to be multiplied times 2 on the left, and I'm going to multiply it times 2 on the right to get rid of my nasty fraction, although fractions are our friends. And I'm going to be left with x plus 15 equals 20. And then just subtract 15 from both sides, and I'm going to be left with x equals 5. So the measure of this base down here is 5. And then you can also do the subtracting shortcut or trick. So to go from 15 to 10, I subtracted 5. To go from 10 to this base, I subtract 5, and then 10 minus 5 is 5. So there's 2 ways you can do this. One's maybe a bit quicker than the other, but either way will get the job done. All right, so here, this type of problem, I've got a parallelogram. I've got a set of sides congruent and parallel. The V's mean they're parallel. So I have a parallelogram here, and opposite angles are going to be congruent to each other. So these two are going to be equal to each other. So I'm going to be left with x equals 90 minus x. And then in order to solve this, I'm going to add x to both sides. Maybe put this down a little. Well, I guess I don't have much boost. Add x to both sides to get the 90 by itself. My x's, not the best x in the world, sorry. There's that one. The x's are going to cancel. I'm going to be left with then x plus x is 2x. So 2x equals 90, and then divide both sides by 2, and I'm going to get x equals 45. So this one's 45 degrees, and this angle over here is also 45 degrees. All right, so classify this figure in as many ways as possible. So first of all, it's got 4 sides, so it is a quad. All right. Next thing I want to do is figure out the measure of this angle. So there's 360 degrees to give away inside of an entire quadrilateral. It's not my best there, oh sorry. So I'll take 360 minus 90, minus 90, minus 90, and that's going to leave me 90 degrees here. Okay, so then that's going to give me a rectangle because all the angles are 90 degrees. Wow, I cannot draw really well with this mouse. Okay, and then the last thing, because I have a rectangle, then I automatically have a parallelogram. And another way to tell for that is opposite angles congruent. So these angles here are congruent to each other. These angles are congruent to each other. So then I have a parallelogram, and I'm not typing that because that's probably take an hour to do that a good job, so I'm stopping. So I've got a quadrilateral, a rectangle, and then I have a parallelogram. And that's all I can do here. There's no sides marked congruent, so I don't have a rhombus, and I don't have a square. All I have is a parallelogram. All right, so on this type of problem, you'll notice I've got a parallelogram here. I've marked opposite sides parallel to each other, here and here, and here and here. And one of those 5 ways that we can prove that we have a parallelogram is that diagonals bisect each other. So in this case, the length of this diagonal from here to here is equal to the length of this diagonal from here to here. So I'll have 6x equals 3x plus 9, and then opposite sides on a parallelogram are equal to each other. So then I'm going to have y minus 98 and 15 equal to each other. So 6x equals 3x plus 9. I subtract 3x from both sides. That leaves me with 3x equals 9. I divide by 3, and I get x equals 3. So in this case, if I put in 3 here, this is 18. And if I put in 3 here, this is 18. So these two are 18. And then these opposite sides are equal to each other. So I have 15 equals y minus 98. And when I add 98, I get 113. So this is going to be 15, and this is going to end up being 15, because 113 minus 98 is 15. All right, the diagonal lengths of a rhombus are 6 centimeters and 8 centimeters. What's the perimeter of the rhombus? So what you're going to want to do is draw out your diagonals first. So you're going to have a diagonal here, you're going to have a diagonal here, okay? And since this diagonal length, this is the shorter one, is going to be 6, and diagonals bisect each other, you're going to have 3 here, and you're going to have 3 here. And then because this one's 8, and again, diagonals bisect each other, you're going to have 4 here, and you're going to have 4 here. And diagonals in a rhombus are perpendicular. That's one of the concepts of a rhombus, is that they're perpendicular. So you've got right triangles inside of here. So to figure out a side length, because that's what you're going to need to do to figure out the perimeter of a rhombus, is you're going to use the Pythagorean theorem. So this is going to be 3 squared plus 4 squared equals x squared. Or you can take x is equal to the square root of 3 squared plus 4 squared added to each other. Another thing you can notice is that this is one of the Pythagorean primitives. This is a 3, 4, 5. Okay. So then I've got a side length then on my rhombus of 5. So 5 centimeters is one of my side lengths. Then to figure out the perimeter is just distance around. So I'm just going to add up all of these together. So 5 and 5 and 5 and 5, it's going to give me 20 centimeters. And there's my problem. All right, I told you I was going to give you a new figure, and what is it? It won't be on the test that you're going to be starting tomorrow. But what is it? Are you ready for it? The new figure? It's a Shrektangle! It is a Shrek made out of nothing but rectangles, rectangle ears and eyes and teeth. So there's your new figure there, Shrektangle. Sorry, that's probably a dumb joke. All right, so assignment list. So for Monday, I want you to do problems 1 through 14. Tuesday, 15 through 28. Send them to me in a new email. Wednesday, I want you to do problems 1 through 3 and 5 through 7. Thursday, 8 through 11 and 14 through 16, and then send those.